Okay, here's a video to show you how to modify a Nukit 222 nanometer ultraviolet torch so that it can run continuously um, on external power like a wall wart like this. You can use quite a different range of wall warts. You can pick anything from 6 volts to about 39 volts. This one is 12 volts, you can see on there, and has to be at least 5 watts. So now, but before we get started though, it's important to recognize that there are actually, well, there's one major reason that they don't run already. Apparently some of the older ones, when they were first introduced, they did run when they were plugged in on the USB-C port, and you could turn it on and use it. First of all, we don't want to have to press the button because we want to be able to put it on the ceiling. The second thing is that, rather, we want them all to turn on as soon as they're supplied with power, which obviously you can't have both because you don't want it to turn on as soon as it's supplied with power on the USB port. Although you could have a switch on the side. Anyway, but the main reason that my limited understanding and partly my personal opinion is that the main reason they didn't do this is that people have a certain very not illogical tendency to shine these things in their faces. They are not dangerous. In fact, they are very far from dangerous, and I strongly encourage you to read the document and, more importantly, read the public spheres discussion, especially what the manufacturer has to say on the subject. They're very far from dangerous. When you compare the ultraviolet exposure to sunlight and other things and experience, but you can't shine it completely like in your face for hours on end. And unfortunately, some people have a tendency to do that, which doesn't make any sense any more than staring at the sun. But so I do believe in this technology. I think it's a great technology, and I'm privileged to be able to work on it a little bit. I got some torches, and I'm going to install them hopefully in a community center in Montreal. So what we have here, just to explain what we're going to come up with, is a DC-DC converter. This takes the voltage from the AC power supply and converts it to 3.5 volts. Then it drops by 0.2 volts with a Schottky diode. And then the 3.3 volts goes into the device, and it taps in just before the driver, which drives the tube. And we're going to open it, and then you're going to see in more detail how it works later. So the main thing is you don't want it to overheat, right? And in my experiments, I found that it does not overheat if you run it at a lower voltage. The higher the voltage you run this thing at, the more heat it produces. So I've done the logical thing, which is just to adjust this adjustable DC-DC converter. It's adjustable, see the little knob there, and just run the whole thing at low voltage, and then we don't actually need a fan. So there is a version which has a fan, and you can see that in the document on how to do that, but you really don't need one for my experiments, especially if you're going to drill these holes a little bit bigger here, and especially if it's going to be pointed upright. But I actually put it horizontal, and I tried blocking the holes, and I ran it for about 3.5 hours. And when I opened it and I measured the temperature, it was only, I think, 47 degrees at the surface of the module, which for electronics is really not that bad. No, the internals of the device is going to be hotter than that. But I was not able to make it overheat, basically. Whereas I have noticed when you run them on battery, they do get kind of hot. And based on my measurements, it's because they're dissipating at least twice as much heat, probably more like 3 times as much heat. So anyway, the best thing is just to feed it at a low voltage, and you don't need a fan. But that explains the things that people are talking about when it comes to how these devices get hot, and yet somehow I don't need a fan, right? So I'm just trying to explain there. Okay, so that's the modified one. Let's put that aside. First thing is to check to make sure that you have everything in your bill of materials. Got to see the document for that, but it's not very many parts. You need the converter, diode, some wires. 15 centimeters is what I specified. You don't really need quite that long. The converter actually comes with some black wires and some red wires, so I'm going to use those. And you need a soldering iron. You're going to need the power supply, solder, scissors are good, some shoe glue, and you're going to need some wire cutters, a drill, 2 drill bits, and that's pretty much it. I mean, it's not really much, all things considered. I like these, which these are only 15 bucks. Honestly, if you're ever going to do this kind of thing, or if you're going to do this thing more than once, these are really good. These are for stripping wires. They make it a lot easier, and they have a little wire cutter in there too, so you can cut wire. Okay, so a lot of people are going to say this video is too long, and I am going to try to edit it down, but in truth, if you actually want to do the mod, you're probably going to just play at double speed, and you'll see what you want to see. Okay, so first we're going to pry the torch open. There's these little clips, and you can see the clips actually. You probably can't see them in the video. Well, you can sort of see it. But there's a dark area here, so you can see where the clip is in the crack. We just pry them open. You see what I do with the motion of the screwdriver. Because of the way the clip works, this actually works pretty well. Like a lot of the time, these clippy things, they break or they can't be opened practically, which is not good design in my opinion, because there's a lot of reasons you have to get in there and maintain and modify things. So you always want to keep the door open to that if you can. Okay, now I'm going to pry it open. See how I'm doing it? I put my fingers like this, and then in the crack, and then part. And I didn't have to do both sides even. Okay, so we have here the driver module. Now people are calling it a ballast. It is not what I would call a ballast. A ballast is just an inductor. That's my limited understanding of from my limited experience with fluorescent tubes. This is not a fluorescent tube. This is an excimer tube, first of all, which runs at a much higher voltage and runs in a very different way. And anyway, this little module here takes care of almost everything we need to do, all the complicated stuff. And the little green circuit board seems to just take care of charging the battery from the USB port. And it turns it on and off. Oops, we forgot to do something. We forgot to test the torch. You should test it first. I'm not going to turn it on now because you do not want to turn it on while it's open. These wires here are very high voltage. They're several kilovolts probably. I've read that these types of lamps work from 4 to 10 kilovolts usually, and the smaller ones are lower voltage. So this is going to be the lower voltage ones, but you see the sheer quantity of very thick insulation there, and there's a good reason for that because a spark can occur in air at about 1.1 kilovolts per millimeter. So if the bare conductors in there, it's probably bare conductor in there, was closer than a few millimeters to this other bare one, there could actually be a spark. And also, if it's close enough to any other electronic device that's grounded, especially, you're going to get a spark, so which would destroy any electronics. So don't do that. But it's interesting. We could take an opportunity to look in there. I did dismantle this thing, and it's not really that hard to take this tube out. So I think there is hope. If you just had a connector there, you could just open the tubes, or just open the device and replace the tubes fairly easily. That's an important concern because we are talking about 3,000 to 5,000 hour operating lifespan, which if you're operating it, say in a hospital, 24 hours a day, that would be significant. But we're generally not talking about a hospital here. We're talking about something a little bit cheaper and easier. I'm going to cut black wire close to the circuit board and the red wire close to the module. And the reason to do this is so that if you cut them in exactly the same place, the problem is that they have a higher tendency to touch if for any reason the insulation failed or anything else. And it's just generally a good technique. I'm going to use my wire strippers to strip the wires here. Make sure you can see that. I'm trying to look at the phone at the same time as I do this. It also makes it easier to hear me because my head is close to the thing. Try not to get little bits of insulation into the device. Anywhere between 5 and 8 millimeters is a good length to strip up insulation. We want a fair bit of metal because we're going to twist the wires together, which more metal makes that a little bit easier. We're going to twist them together and then we're going to solder them together. And then we're going to coat them with shoe goo, which is a good material to use because it's got lots of other purposes, but it's also a great electrical insulator. It's just rubber mixed with a solvent. What I do is also put it in this orientation while I'm soldering it because I don't want the solder to drip on the PCB, the green circuit board there. This insulation is so soft you can just use your fingernail. This is the silicone stuff, so that's convenient for do-it-yourselfer type stuff. So I start with the red wires. Doesn't really matter which one you start with, of course. I cut the red wires a little bit too close, didn't I? Okay. Twist one of them on. the other one on. So this again, slightly too short. I was distracted by making the video. Go. Okay, so go for 8 millimeters, not 5. Put this on, look like this. Solder it together. Is my soldering iron ready yet? Yeah, it looks like it's about ready. So a lot of people don't like soldering, but honestly, it's not really that hard. And it's definitely something you gotta have to do if you want to do this kind of thing. It's not really anything around it. Can you see that? Yeah, you can sort of see that. Okay, so that's soldered on. I'm not gonna try to do a tutorial on how to avoid cold solder joints or other things could go wrong with soldering. I'm just gonna roll ahead. Yeah. And I can get all 3 wires together at once. Yeah, I don't really need to move it. You just don't want solder dripping on that circuit board. Make sure it's good. You don't want any cold solder joints. I'm going to turn the soldering iron off for a few minutes. I don't burn myself on it or anything else. And then what we're going to do is we're going to coat that with some shoe goo. I have some, this stuff is good. This is called liquid tape, but I'm not going to use that because nobody else is going to want to buy that because it has no other use except for this. So we're just going to go, I like shoe goo partly because it doesn't go bad in its container. I'm going to contaminate the shoe goo tube with some solder. Do not use lead solder. I'm not going to talk about that much. It's not generally a good idea. Make sure that you've covered everything thoroughly. Oh, this is interesting. Module's broken. When I put the tube back on again. That didn't work very well. Make sure you tighten the tube really well. Tighten the cap of the tube, rather. Clean the screwdriver off. It doesn't take very long to evaporate when it's just a small amount like that. So what we're going to do is the next thing on here's how we drill the holes. Drill bit in. scissors to clean up the holes. And I'm going to drill a hole for the wires. Now that we're all here. Now we want to okay. Now make sure the shugu is dry. Yep, seems good. I'm actually going to tie a knot in the wires, which is optional. But just in case somebody pulls on the wires at some point, I don't want it to pull on the stuff inside any more than it has to. So about there's good. Oops, you can't see that. Okay, so I've tied a knot in the wires. They're about the right spot. Wires through. Now we can close the whole thing. Make sure you have a look in there. Make sure everything's good. The most important thing is to make sure that these connections are very well covered with shugu. You do not want any metal exposed, lest it short circuit. This driver, it just sort of goes there. Honestly, this carefully put it together. There. And again, the most important thing here is to be afraid of the high voltage inside. You don't want it escaping in any way. The shugu is going to help a lot with that. But I probably should have put these wires over here. But anyway, the point is that there's room for a fan here if you want. So that's why the wires are here. We can turn it on and see if we broke it. Not a bad idea, seems to work okay. Okay, now, okay, so we go in negative. Notice the little white letters on there. Can you see those? Anyway, you can see them in real life, no problem. There's in plus, in minus, and out minus are actually connected together. So what I'm going to do is put the wires through the hole, and then you bend them a little bit. These wires happen to be soldered already on the end a little bit, but if they weren't, then you'd want to twist them. We're going to solder this side of the device together first. Go. So don't solder the other side yet. We're not ready for that yet. Just going to leave the soldering iron on. Now fire up your voltage ohm multimeter, your VOM. Actually, now I suggest you use this side of the connector for the torch. Usually the socket is the one that is the power supply, although unfortunately that's been reversed in some instances. So I'm going to connect. Again, power flows from the right side to the left side, just the same as we read. I mean, that's the convention. So then we want positive to be high, negative to be low. That's just the convention. Well, you open the screw terminals, put the wires in there, you screw them down. Now, the problem with these connectors is that they are great, they're very handy, but the wire is just metal where it goes into the thing. So you can't bend around a whole lot. You've got to be careful with it. But because the wires are flexible, that's not generally a big problem. Now, the other side is this is the power supply. So I already cut the end off the power supply, but they usually come with a barrel connector. I don't really like the barrel connectors. I like these screw terminal connectors more. I cut the end off, and you'll see that they actually have a stripe usually on one side. That's the ground wire, and the other one is the positive wire. But just in case you don't know, you can use your multimeter to check the polarity. I'm just going to check it just to be sure. Yeah, it's positive 12 volts, negative 12 volts, well, ground. Okay, so you get the other wire, put them together so that you can tell which one is which. Don't have the wall wart plugged in while you're doing this. You don't want to make a mistake. And at the top facing you, bottom is ground. Make sure it stayed in there. Open up the clamp. You can look in there and see, make sure it's opening. Now we have power supply connected to the converter. Then we're going to adjust the converter so that it gives 3.5 volts out. Have your screwdriver. Got to plug in the nice brass screw, which I know you can hardly see really, but it's in there. If you turn it the wrong way, it won't do anything because the voltage is already, this converter can only step down, not up. It'll start clicking when you get to the extreme end. So that means you went too far one way. Okay, now it's starting to go down. It took a little while. Very long traverse. Get it down to 3.5. Back up again. There we go. That's that. Now unplug the wall wart. Wait for the light to turn off. You don't really want to mess with it when it's not turned off. I'm going to plug in out minus and out plus. Probably better that it's out of them. one by one. Oops. I almost forgot the diode. Okay, we want to connect the diode here. Just leave the wires, make sure you get it the right way. The bar has to go, see there's a little gray bar. If the camera would focus right, you'd be able to see it. Okay. There, you can see there's a bar on this side. Now the current flows, the electrons flow from this side to this side. Okay, we can turn the setting off, iron off now. Not gonna use it again, unless you're adding the fan. Cut these leads off. Then I'm gonna tape. Probably be a good idea to test it before you tape it down, but it doesn't really matter much. Some tape. This is the good tape. Measure the piece out. Okay, now give it a try. I'm just gonna plug in the wall wart. I got to plug in. I have to unplug the lamp every time I do this. And it turns on. Probably a good idea if you haven't done this before to check everything thoroughly. Think about it for a minute or two. Make sure you haven't forgotten anything. Make sure the polarity here is right. It has to be right at every stage, of course. And that's pretty much it. We already tested the DC-DC converter while we were adjusting it, so we don't have to worry about that. I'm going to put another piece of tape on there just to cover those electrodes. Don't cover the hole, of course. And that's it. Now you can unplug it, you can carry it around. Let's check to see if it works on the battery. Did we destroy it by accident? No, we didn't. Okay, we're successful in our surgery. Everything is taped shut, so we don't have to worry about getting a shock or anything. And it works on both the battery and external power. It powers up automatically as soon as it receives power, which is what we want if you're putting it on a ceiling. You don't want to have to reach up there and press the button. So that's it. Now again, the important thing is Nukit is already making perfectly good ceiling mount version, which is not going to require any of this slightly hazardous and laborious undertaking. So just make sure you buy that instead if you can. For me, I didn't want to wait, and it's not clear that we're going to be able to get those fixed install ones here in Canada because there's a lot of regulatory issues. And also, I kind of like the dual use thing. This is for a community center, so they can take it off the wall and they can do something else with it if they want. I'm thinking put a piece of Velcro on the side here, and then you'll have like an L bracket, put it in the corner of a room so it's pointing down like this. So you've got the convection for the cooling, and it's also pointing into the room the way it should. Whereas if you put it on the ceiling, it's a little more awkward. You can still do that, but anyway, that's it.